So by completing this problem, we have completed the whole session for the fifth module. Okay. So we have completed all the sessions, all the topics. We have covered all the topics in our syllabus, and we have successfully completed the whole syllabus portion in our subject. So today we want to discuss about some problems related with the steam tables. So how to do a problem with using steam table. So it is for fourth module. So today I'm starting the revision of fourth module. That is the problems related with or problems using steam tables. Okay. So please write down a problem, and we can discuss how we can do by using steam tables. Calculate the internal energy. Calculate the internal energy per kilogram of superheated steam at a pressure of 10 bar. At a pressure of 10 bar and a temperature of 300 degrees Celsius. 300 degrees Celsius. Also find the change of internal energy of this steam energy if the steam is expanded to 1.4 bar and dryness fraction is 0.8. So problems using data book or problems using dryness fraction will be asked like this. Okay, you can expect this type of problem in your university question paper also. So here you want to find the internal energy per kilogram is superheated steam at a pressure of 10 bar and temperature of 300 Celsius. So these are given data. Pressure is given as 10 bar, temperature is given as 300 degrees Celsius. Okay. So please write down the given data, that is pressure is given as 10 bar, temperature is 300 degrees Celsius. Then after finding the internal energy per kilogram, you also want to find the change in internal energy. That is, if the steam is expanded to 1.4 bar. So initially we have a pressure of 10 bar, and this steam is expanding to 1.4 bar. The pressure is reducing and the gas is expanding. And the dryness fraction of the expansion is 0.8. So you want to find the change in energy after the process. That is, you want to find the final internal energy also, and total U2 minus U1. So initially you are finding internal energy, that is calculated energy per kilogram of superheated. So initially just you are finding internal energy U1. Thereafter it is expanding to 1.4 bar, and you also want to find the second or final internal energy U2. Then U2 minus U1 will be your change in internal energy. That is the question. So take your gas tables or steam tables and find out the data as we needed. So here the equation for change in internal energy. Okay, change in internal energy. Sorry, not change in energy. Calculate the internal energy of superheated speed. Internal energy of superheated speed is given by U1. Take U1 equal to, what is the equation of U internal energy? Initial, generally, commonly, what is the equation? You know that H equal to U plus PV, right? Enthalpy equal to internal energy plus pressure over H equal to U plus PV. Therefore, U equal to H minus PV, right? H equal to U plus PV enthalpy. Therefore, U equal to H minus PV. So U1 equal to of superheated of superheated. Therefore, H superheated minus pressure is constant. Pressure into V superheated. That is the equation for internal energy superheated steam. U1 equal to H superheated minus P into V superheated. So you want to find the pressure is given here 10 bar. 10 bar. Then H superheat you want to find out, and V superheat also you want to find out. So how can we find the value of H superheat and V superheat? That is enthalpy of superheated steam and volume of superheated steam. Can we find by using your data book? Okay. So here we have at pressure 10 bar and temperature 300 degrees Celsius, right? So here first of all you have a superheated steam, the pressure 10 bar and temperature of 300 degrees Celsius. So at 10 bar and temperature as 300 degrees Celsius, take your table, take your gas tables or superheated steam. We have three tables here in our gas tables. You have three tables. First one is for saturated vaporized steam of temperature stable. That if temperature is known, we can find the other data in the temperature table. Then after that page, you have a pressure table. The same table, when pressure is given, you can find the value. The temperature on the then after pressure. Thereafter, we can find a table with superheated steam. Okay. Superheated steam at various pressure and temperatures. From that table, our pressure is 10 bar. So please take the section at a pressure as 10 bar. Pressure as 10 bar. We have reached pressure 10 bar. The temperature is 300 degrees Celsius, right? 300 degrees Celsius. To take the region where pressure as 10 bar and temperature as 300 degrees Celsius, we can find the value of H. Pressure as 10 bar. We have when we can see the pressure as 10 bar, the next column is you can see V, U, H and S. Four values are here. First one is volume, internal energy, enthalpy and entropy. Four values are there. So there are different tables for different values. So which value you want to take? So you know that the temperature is given as 300 degrees Celsius. 300 degrees Celsius. When pressure 10 bar and 300 Celsius, just we can take the reading here. Temperature is given in your right top 50, 100, 150, 200, 250 and 300. Okay. Give down. And when we reach at the point where the pressure is 10 bar and temperature is 300, we get a point of H here. That is H superheat. H superheat can be found out by using that value. The value is what's the value? Or no?
3051.2.
Yes, it is 3051.2. H superheat. Page number, data book page number or from superheated steam table. Superheated steam table. Very good. From superheat steam table, H superheat is given as 3051.2. 3051.2. Unit is kilojoule per kilogram Kelvin. Kilojoule per kilogram Kelvin. 3051.2. It's superheat. At that time, temperature is given as 300 degrees Celsius. So we can convert the 300 degrees Celsius into Kelvin also. Our T and T superheat equal to 300 plus 273, that is 573 Kelvin. 573 Kelvin is the T superheat. It is given a problem. Temperature of a steam at superheated state is given as 10 bar. Pressure of superheated pressure is 10 bar. Superheated temperature is 300 Celsius. Superheated enthalpy is we can get the value in table free 3051.2 kilojoule per kilogram Kelvin. Not Kelvin, Kelvin at all. Kilojoule per kilogram. Kilojoule per kilogram. Then H superheat is already H pretty. Pressure is 10 bar, and we want to know the value of V superheat. V superheat. But T superheat is already there. T superheat is 3051.2 kilojoule per kilogram. Then V superheat is the value you may find out. So we can use Charles law. Charles law to find the value of V superheat. We can state a relation. What was Charles law? PV equal to constant Boyle's law. Then Charles law is there at a constant pressure and constant temperature. We know the two laws. First one is Boyle's law. We had already studied in +2 chemistry or like that. Charles law and Boyle's law. Okay. At a constant pressure and constant temperature. We know that by using Charles table, V by T equal to constant. That is at a constant pressure, V directly equation to T. At a constant pressure, V is directly proportional to T. Therefore, V by T equal to constant. The Charles law. So using Charles law, you can find the value of V superheat. It is relation another go Vg by Ts equal to P superheat by T superheat. Vg means normal volume or specific volume of gas and the saturation temperature Ts. Vg by T. Saturated state equal to superheated state. That is the equating that is. Saturated state equal to superheated state. That is Vg by Ts equal to Vt by superheat. Okay, V by T equal to constant. That is V1 by T1 equal to V2 by T2 equal to V3 by T3 equal to etc. Vn by Tn. That is the law. V by T equal to constant. Therefore, we can take the relation Vg by Ts, the saturated state equal to V superheat by T superheat. So T superheat is known value. T superheat is known value. Then Ts കണ്ടുപിടിക്കാം. Vg can you find out? Ts can you find out? Vg ds കണ്ടുപിടിച്ചിട്ടില്ല. So Vg ds കണ്ടുപിടിക്കണം. So how we can find the value of Vg and Ts? So we have 10 bar now, right? 10 bar ഉണ്ട്. Initially we had taken superheated steam table for find the value of H superheat. So അതിന് മുമ്പത്തെ പേജ് ഞാൻ പറഞ്ഞു there is a table with respect to ടെമ്പറേച്ചറും പ്രഷറും ഉള്ള ടേബിൾ ഉണ്ടെന്ന് ഞാൻ പറഞ്ഞു. തൊട്ട് മുമ്പേ നമുക്ക് 10 ബാറാണ് പ്രഷർ ഉള്ളത്. 10 bar pressure പോയി കഴിഞ്ഞാൽ നമുക്ക് Ts കിട്ടും Vg കിട്ടും. Ts and Vg, we will get the value of Vg and Ts from the table just before that superheated table. Pressure ആണ് നമ്മുടെ കയ്യിലുള്ളത് അല്ലേ? പ്രഷർ ഉള്ളതുകൊണ്ട് പ്രഷർ ടേബിളിലേക്ക് പോവാം. 10 bar pressure table. Pressure table 10 bar page. Okay, 10 bar. What is the Ts value? Pressure കിട്ടിയാൽ നമുക്ക് എന്തൊക്കെ വാല്യൂ കിട്ടും? Ts, HF, HFG, HG, SF, SFG, SG, BF and BG. All value will be get by knowing only one pressure. We have our pressure as 10 bar. So what is the Ts value?
179.9.
Very good, very good. At a pressure 10 bar from saturated table, ഇന്ന എഴുതണം കേട്ടോ, ഇതിൻ്റെ മാത്രമേ മാർക്ക് കിട്ടുള്ളൂ. വി ഹാവ് ടി എസ് വാല്യൂ ഈക്വൽ ടു 179.9 degrees Celsius, right? Degrees Celsius, comma, what is the value of Vg? Value of Vg?
0.194.
Very good. 0.194. Unit is unit mole കൊടുത്തിട്ടുണ്ടാവും. Meter cube per kilogram, right? Meter cube per kilogram. So you have the value for Ts and Vg here. So we can actually find the value of V superheat. Then V superheat equal to Vg by Ts into T superheat. Take the value of temperature in Kelvin. Okay. Ts value from 179.9 degrees Celsius. Take the value in Kelvin. That is Vg. Vg is 0.194 divided by Ts. Ts is 179.9. That is 179.9 degrees Celsius plus 273. Plus 273. 452.9 into T superheat. T superheat is 594. 573. 300 per 273. 573. You will get the value of V superheat. ഇങ്ങനെയാണ് കണ്ടുപിടിക്കേണ്ടത്. If pressure is given, you can actually go to the pressure table. You can get the whole value, Vg, Tg, USG, HFG, anything. If temperature is given, you can go to temperature table. If you want to find the properties of superheated values, you want to go to superheated table. V superheat equal to 0.245. 0.245 meter cube per kilogram. 0.245 meter cube per kilogram. So here we got the value for V superheat. So the whole thing you find the value of internal energy. U1 equal to superheat means PV superheat. Therefore internal energy equal to 0.245 meter cube per kilogram. Therefore internal energy U1 equal to H superheat minus P into V superheat equal to 3051.2 minus pressure is given as 10 bar, that is 10 into 10 power 5 Pascal. Pascal into V superheat 0.245. 0.24 meter cube per kilogram ആണുള്ളത്. അതിൽ നമുക്ക് കിലോഗ്രാം ഒഴിവാക്കണം. കിലോഗ്രാം ഒഴിവാക്കി എഴുതണം. കിലോഗ്രാം ഒഴിവാക്കുമ്പോൾ അങ്ങനെ എഴുതാം. If you want to add a kilogram, you want to multiply the value in 10 power 3. ഇവിടെ per kilogram ആണുള്ളത്. Meter cube per kilogram ആണ്. So kilogram is inside. So you want to delete it into 10 power 3 അടിയിൽ കൊടുക്കണം. അത് മുകളിലേക്ക് വരുമ്പോൾ 10 power minus 3 ആവും. Therefore 0.245 into 10 power minus 3. You want to take the kilogram value. Kilogram Pascalക്ക് മാറ്റി. So അത് കിലോഗ്രാമിലേക്ക് മാറ്റണം. So that is per kilogram is there. So we will be adding in 10 power 3 in denominator. When the value goes on the numerator, the value will become negative, at least 10 power minus 3 meter cube per kilogram. Not kilogram, that is per kilogram, that is denominator. When we add 10 power 3, it goes up, it changes to 10 power minus 3. So you will get the value for internal energy directly. The value will be 2806.2 kilojoule per kilogram. 2806.2 kilojoule per kilogram. So first question is complete. calculate the internal energy per kilogram of superheated steel. So, therefore, equation is U equal to H superheat minus P into V superheat. So, H superheat, the value we already get by using that above. V superheat also, by relation, I'm using a charge table, Vg by Ts equal to V superheat by T superheat. Vg value, Ts value can be found by using gas tables. The pressure is given. Thereafter, V superheat is find out. And finally, internal energy, 286.2 kilojoule per kilogram. Then the process happening, the expansion process happening, and the pressure reaches to 1.4 bar. Dryness fraction only. Dryness fraction question പറഞ്ഞിട്ടുണ്ടെങ്കിൽ you want to include the dryness fraction, no problem. ഇവിടെ നമുക്ക് എന്ത് ഇക്വേഷൻ ഉണ്ട്, U equal to H minus PV അല്ലേ. You want to add H minus P into the V will become X into V. Dryness fraction X will be also adding to that, multiplying into the product PXV. Dryness fraction is the a fraction multiplied in the way in the equation Vg. Vg equation was the X that U equal to H minus P value. You want to here find out U2 equal to H minus PXVG. Expansion value. U2 equal to H minus P into XVG. X value is given a problem 0.8. So you want to find U2 here, that U2 equal to H minus P into X into Vg. H superheated at all. Initially, simple X. That is, there are expansion is happening here. H minus P into XVG want to be find out second one, and U2 minus U will be the change in internal energy. So how we can find the value of H? Later by studying from the section pure substances, we have written so many equations there. H equal to U equal to S equal to SF plus XFG. പഠിച്ചിട്ടില്ലേ? U equal to H equal to HF plus X into HFG. S equal to SF plus X into SFG. Like that, we have studied so many equations here. So by this method, you can find the value of H, HF plus X into HFG. So from where you will get the value of HF and HFG? From our table. And the pressure is given here. 1.4 bar is the pressure after expansion. So you have pressure here. From the table, you can find the value of HF and HFG. Directly given the, substitute the value, you can find the value of H. Okay. Pressure 1.4 bar from gas tables. Pressure equal to 1.4 bar. HF value, HFG value, even VG value, we can get the VG value. Take off table, whole table, at pressure table, and pressure is 1.4. Take the table with the 1.4 bar pressure. Is there. What is the value of HF, HFG, and VG? After expansion, the pressure reduced to 1.4 bar. What is the value of HF? And the pressure is 1.4 bar.
458.4.
Very good. 458.4. 458.4 kilojoule per kilogram. HFG value.
Two two 2231.9.
2231.9. 2231.9. സെയിം കിലോ ജൂൾ പെർ കിലോഗ്രാം. യൂണിറ്റ് മോൾ കൊടുത്തിട്ടുണ്ട്, കാണുന്നില്ലേ? ഏറ്റവും മോൾ യൂണിറ്റ് ഇട്ട് കിലോ ജൂൾ പെർ കിലോഗ്രാം. വി ജി വാല്യൂ
1.236.
1.236. 1.236 meter cube per kilogram. So all data, we have got the all data to find the value of U2. Okay. H കിട്ടാൻ വേണ്ടി you know that HF we need the value of HF and HFG. The value already got. HF plus X is known, HFG is known. Then after substitute the value of H here, we can find the value of U2, that is H already got. P is 1.4 in 10 power 5. X is known value. PG is also known value. So this is a very simple question. So find the value of H first. So for H is equal to HF plus X into HFG. So select question you want to find, it is there asked to find the value of X itself. So some question you want to find the value of dryness fraction. The question will be asked, find the dryness fraction if the other all values are given. If H value will be given there, HFG value, HF value can be found by using a pressure is given, sir. So you want to find the value of X itself. Some question is the probably textbook. So here, dryness fraction is given 0.8. HF value is 458.4 plus 0.8 into 2231.9. The value is 2243.92 kilojoule. It's super, therefore kilojoule only. Kilojoule. Then the value of U2, H minus P into X into Pg. Dryness fraction ആണ് X വരുന്നത് കേട്ടോ. That is H value is given as 2243.92 minus 1.4 into 10 power 3 into 0.8 into 1.236. So previously done, when we are taking the value of Pg, we want to take 10 power minus 3 to convert the whole value in SI unit. Meter cube kilogram. If it is meter cube into kilogram, you want to take in 10 power 3. Here it is meter cube per kilogram. Then we are adding meter cube per 10 power 3. When 10 power 3 goes up, it reaches to meter cube in power minus 3. That is 1.26 into 10 power minus 3. Converting it into unit of SI unit. You will get the value of U2 directly. 10 power 3, 1.4 and 10 power 5 on top. Converting it to Pascal, the value will be 1.4 and 10 power 5. 1.4 into 10 power 5. The whole value of U2 will be 2105.49 kilojoule. Superheat stage control maatrame kilojoule per kilogram. It is in kilojoule. I have already converted the value. So here U1 and U2 is already found out. U1 and U2. Therefore, the question is asking change in internal energy. So change in internal energy is air value minus lower value, or U2 minus U1, final minus initial. Change in energy, final minus initial. You want to find the value of U2 minus U1 only, not higher value minus lower value. Change in energy minus means that last value minus initial value. If the value is negative, you can say that the change is decreasing. If it is positive value, we can say that change is increasing. Okay, so only you want to find the value of U2 minus U1 only, not if you have the higher value as U1 here. So you don't want to add the value higher value minus lower value. You just subtract the value not final value minus initial value. U2 minus U1 only. You will get the value is negative. You can say that the value is negative. It means that the entropy is decreasing. So here u2 minus u1 means 210.449 minus 2806.2, that is minus 700.7, minus 700.7 kilojoule u2 minus u1. Then write down that negative sign shows entropy is decreasing. If it is positive value, we can write that positive side shows the entropy is increasing. So this is the method of solving problems using data book. Pressure or temperature will be given in your problem. So you just need to find out whether which table you want to go and which value you want to take. It depends upon the question, which means what you want to find out. Here you want to find out the internal energy. U2, sorry, entropy, internal energy. U2 minus U1 means internal energy. So you want to find out the internal energy initially. You have an equation. So by the equation, which value you want to find out, that depends upon how you which value you want to find out. That means you want to take either pressure table or temperature table or superheat table. So second case, the dryness fraction is given there. So the equation will be H into P into X into Eg itself. So here H you want to find out. H means H of saturated state. HF plus X into HFG. That is the equation of H. If S is the SF plus X into SFG. Okay. It is clear. If any doubt is there, you can ask me directly or call me. Tomorrow, we can discuss another problem to deal with the same data book.